Hello and welcome to a new section on 4.2 congruent triangles. So we're continuing our triangle unit, and congruent triangles is something relatively new. We do know what congruent means. We'll go ahead and get this title down. I noticed that I'm on the next page because I ran out of room. So go ahead and get that down. Pause the video if you need to. Going to page 27 and 4.2. This is actually not a continued. Let's actually erase that. And congruent triangles. We know what congruent means. Congruent means equal in measure, whether it's an angle measure or a line measure or line segment measure. And then obviously triangles means we have a three-sided shape. So congruent triangles means, and let's go ahead and get this down. Congruent triangles means this. These are triangles with the exact same shape. And notice I'm going to underline the exact same shape and size. Okay, so what I mean by this is if we have two triangles here, what I'm going to do is I'm going to highlight this, copy it, paste it, and line them up. Doesn't have to be lined up to actually. Let's, for the sake of it, let's put it off alignment. So I'm going to say A, B, C for this first triangle, and then I'm going to put X, Y, Z. Okay, and I'm going to state here that triangle ABC is going to be congruent to triangle XYZ. Okay, so what this means is this. This is the kicker. Every triangle that's congruent has a corresponding part, meaning corresponding parts are congruent. Okay. So here's how I want you to kind of understand this. We have corresponding parts. Corresponding parts of congruent triangles and I probably should have spaced this out a little bit more. Corresponding parts of congruent triangles are congruent. Okay, this is also known as CPCTC. Wow, I probably should have given you a lot more space to start this off. And this is essentially what this means. We have CPCTC. We are going to be writing this out a lot actually in the upcoming lessons. But corresponding parts of congruent triangles are congruent. We clearly see that these two triangles are congruent, which means the corresponding parts are also going to be congruent. And that's where naming this triangle is actually very, very important. If you notice, angle A, so let's talk about angles. And specifically, corresponding angles. So we could say, for instance, corresponding angles. I don't have enough room. So corresponding angles is based off of its name. Okay, we could say A is the first letter and X is the first letter, which means those are the respective angles that are congruent. Angle A will be congruent to angle X no matter what the angle is. So if I put, for instance, this was 50 degrees, then angle X by default has to be 50 degrees based off their position or the name of the triangle. Okay, but we're not going to do that. We're not going to fill that in. We're just saying that they are congruent. We're not going to put the actual measures in. So notice that B and Y are the second letters. So that means B by default has to be congruent to angle Y because they are corresponding angles. And last but not least, we have angle C, which is going to be congruent to angle Z because in the name, in the congruence name, Z's are the third letters. Okay, so what about sides? What about corresponding sides? Okay, if we have corresponding sides, then we take this into effect. The fact that AB are the first two letters lines up with XY, the first two letters of the second triangle, those two parts have to be congruent. And we should have done this. I should put tick markers here. A with X, B 2 ticks, Y 2 ticks, and then a C 3 ticks, with Z for 3 ticks. Okay, and we could actually do the same for corresponding sides. So corresponding sides would entail, like I said, AB and XY, because those are the first two letters to make a side. AB is going to be congruent to XY because of where they are positioned in its congruence statement. So we have AB 1 tick with XY 1 tick. BC as the second and third, YZ is the second and third. So we could say BC, segment BC, or side BC is going to be congruent to segment YZ. Okay, and we could take that as well. 2 ticks, 2 ticks. And then last but not least, we do the first and the third letter, AC, is going to be congruent to the first and the third in the second triangle, XZ, or ZX, however you want to state it. Doesn't quite matter, because as you see in the triangle, it will be that last segment, last side. 1 2 3, 1 2 3. Okay, so this is what corresponding parts of congruent triangles are congruent. CPCTC. We will use this. We have congruent triangles, then all the corresponding parts are going to be congruent, based solely off of its name. Okay, so when you prove that triangles are congruent, corresponding parts need to be congruent along with it. And you'll see what I mean in the later lesson. Okay, so just really quickly, just running back through this. Since we have this statement, triangle ABC is congruent to triangle XYZ. If I put a 10 here, by default XY would have to be 10. If I put 12 for BC, then by default YZ should be 12. And we keep going. We could say this is 18 for AC, which means XZ has to be 18 as well. Okay, so just a quick example. That's pretty much that's all I have for you today. If you do have any questions, please let me know, and I will see you in the next one. Bye.